I'm going to go over the 11.41 practice problem. That document is attached. You can pick that up in Google Classroom. All right, so it says many suppliers use inspection procedures for quality control. Sure, why not? You want to see if you're sending out a good product. You probably should make sure that it's working. For example, a contract between a manufacturer and a consumer for light bulbs may specify that the average lifetime of the bulb must be at least 1,000 hours. Makes sense. You don't want to have a light bulb that's going out after only a couple hours of use. So as a part of a quality assurance program, the manufacturer institutes an inspection program, and they look at 10,000 units, 10,000 light bulbs, good grief. So yada, 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 we come up with these hypotheses. So they're going to accelerate the testing life, and that's going to be the equivalent of 1,000 hours. So our null hypothesis is that the average is equal to 3 accelerated hours. So that means they're getting 1,000 hours worth of light bulb use in just 3 hours of time. So they're turning it on and off a whole bunch and throwing some extra stuff at it. The alternative is that it's less than that it's not meeting standard. Okay? So they're going to take 100 bulbs at random per day, and they're going to reject all 10,000 that they make. They're going to reject all of them if they reject this null hypothesis. So that's crazy. My alpha, 0.05. Throw out all the bulbs if we fail here, all 10,000. So we're going to describe a type 1 and type 2 error in this particular setting with light bulbs, and what consequences would be associated with each type of error. So let's just kind of remind ourselves here through the use of the matrix. So null hypothesis is true, null hypothesis is false. We reject the null hypothesis or fail to reject the null hypothesis. So when the null hypothesis is false, we want to reject it. So that's good. That would be thrilling. I'd love for that to happen. Or if the null hypothesis is true, we fail to reject. That's also good. Let's put this in terms of this particular problem here real quick. So if the null hypothesis is true, then the bulbs, the light bulbs, are good. And they're lasting how long they should. And if the null hypothesis is false in this particular problem, then the bulbs are bad. Something's gone wrong with the manufacturing process and the bulbs aren't lasting as long as you want. So what happens in a type 1 error when you have good bulbs but you reject the null hypothesis? So type 1 is good bulbs but we say that they're bad. So what happens in this situation? We throw out or sell at a reduced price or in some way get rid of good bulbs. And the company loses money, right? They had perfectly good bulbs, they decided they weren't, and so they chucked them or sold them at the dollar store. I don't know. What happens in a type 2 error? In a type 2 error, here's the reality of the situation. The bulbs are bad, but we fail to reject. We've got bad bulbs. But we say they're good. So what happens in this particular situation? If you think the bulbs are good as a manufacturer, you're going to sell those bulbs. You're going to put those out onto the market. So if we're saying they're good, we're going to try to sell inferior bulbs. And what that might do is tarnish your company's reputations. And that's bad, because then the consumer won't buy your product in the future and you lose money. So which is worse? That's kind of up to you. I feel like you could debate your way into one of these worse. So just use your skills to come up with a claim why which is worse. I think personally that type 2 is worse, because if you are trying to build the reputation of your company and some bad products get out there, that could ruin your company's reputation and potential future sales. That's bad news. If you get rid of one batch of bulbs, that's a small impact as compared to what the future might hold for a type 2 type situation. So that was question number 1. Question number 2 says, explain clearly 2 different things that could be done to increase the power of the proposed test procedure. Well, we learned in one of our previous lessons that to increase power, we can do 2 very simple things. Increase power through increasing alpha. So as I create this probability, if I increase the probability of a type 1 error, which we said is the better of the 2 bad choices, then that reduces the probability of a type 2 error. Another thing to do is increase your sample size. So if you increase your sample size, that makes coming up with the correct conclusion more likely. Of course, that comes with costs. It's probably not cheap or easy to test light bulbs at an accelerated rate, but how badly do you want to produce a good product? So these 2 things, really easy ways to increase the quality of your hypothesis test, the likelihood that you correctly reject a null hypothesis that is false. All right, that is problem 11.41.